Gold, one of the most coveted elements on Earth, has long fascinated humanity for its beauty, rarity, and value. But have you ever wondered about the cosmic origins of gold? Is it truly made in stars? As scientists suggest, the answer lies in the incredible processes that occur during the life cycles of stars, specifically in the violent events that mark the end of certain massive stars. In this video, we will dive deep into how gold and other heavy elements are formed in the cosmos and how they make their way to Earth. To begin, it's important to understand that elements like gold, platinum, and uranium are what we call heavy elements. These elements are much rarer than lighter elements like hydrogen or helium, which are created in the cores of stars. The formation of heavy elements is one of the key mysteries of stellar astrophysics. While stars like our Sun primarily produce lighter elements through the process of nuclear fusion, the creation of elements heavier than iron requires a different kind of process, one that occurs in extreme cosmic environments. Supernovae, the explosive deaths of massive stars, are one of the main sources of heavy element production. When a massive star reaches the end of its life cycle, it runs out of fuel and undergoes a dramatic collapse. This results in an explosion known as a supernova, which can outshine an entire galaxy for a short period. During the immense energy and pressure of this explosion, nuclear reactions occur that allow atoms to combine and form heavier elements, including gold. These explosions generate such intense temperatures and pressures that they create the conditions necessary for fusion processes that produce elements beyond iron in the periodic table. But supernovae aren't the only place where gold is formed. Another cosmic event known as a neutron-star merger plays an equally important role in the creation of heavy elements. Neutron stars are the remnants of stars that have exploded in a supernova. They are incredibly dense, with a mass similar to the Sun but packed into a sphere just a few kilometers across. When two neutron stars collide, the resulting explosion is one of the most energetic events in the universe. This kilonova explosion is believed to create vast amounts of heavy elements, including gold, platinum, and other precious metals. These elements are then scattered across space and can eventually become part of forming planets, like Earth, after billions of years. Now, let's talk about how gold actually ends up on Earth. After being created in supernovae or neutron star mergers, the gold particles are scattered throughout the universe. Some of these particles will become part of the gas and dust that makes up new stars, planets, and moons. Over time, some of the gold and other heavy elements make their way to our solar system. During the early stages of Earth's formation, a process known as planetary accretion occurred, where particles of dust and gas collided and stuck together to form planets. This process, which took place about 4.6 billion years ago, incorporated all of the elements present in the solar nebula, including gold. It's also worth noting that gold is found in specific concentrations on Earth, often in geological formations like veins, deposits, and ores. These concentrations are the result of geological processes that occurred after Earth's formation. During the late heavy bombardment, a period about 4 billion years ago when our planet was heavily bombarded by asteroids, significant amounts of gold, along with other precious metals, were delivered to Earth. Some of this gold is believed to have been deposited in Earth's core, while the rest remained in the crust, where we can mine it today. While we know that gold is indeed created in stars, the process is incredibly rare and requires very specific conditions. The fact that gold exists on Earth is not only a result of cosmic events but also a product of our planet's unique geological history. Without these catastrophic stellar explosions and the subsequent processes that brought gold to Earth, we wouldn't have the precious metal we value so highly today. Gold's cosmic origins also remind us of the interconnectedness of all things in the universe. The elements that make up our planet and even our bodies were forged in the cores of stars, and many of them were scattered across space during supernovae or neutron star mergers. This means that every atom of gold on Earth, and even the atoms in our own bodies, were once part of distant stars that lived and died billions of years ago. Understanding where gold comes from also ties into broader principles of stellar evolution and nuclear astrophysics. The life cycles of stars, from their birth to their explosive death, are essential to understanding how the universe recycles matter. In this context, stars act as cosmic factories, continually producing and distributing elements that are vital for life and the formation of planets. The study of these processes gives astronomers a deeper insight into how our universe works, how it has evolved, and how the elements that make up everything we know came to be. In conclusion, gold is indeed made in stars, but its creation is far from a simple process. It requires the extreme conditions found in supernovae and neutron star mergers, where the intense heat and pressure allow atoms to combine and form heavy elements. These elements are then scattered into space and incorporated into planets like Earth, where they can be mined and appreciated by humanity. The story of gold's cosmic origins is not just about precious metals, but about the broader principles of stellar evolution and the processes that shape the universe. As students of astronomy, understanding how gold and other heavy elements are formed allows us to appreciate the complex and interconnected nature of the cosmos. Gold's creation is a reminder that everything around us, even the most valuable things, has a story that stretches back to the very beginnings of the universe.